All right, so now we are discussing pressure um, volume loop. Pressure volume loop is just that it is derived from us comparing what is happening in the ventricle in terms of pressure against the volume changes that we're able to see. So this is an example of what is happening in the left ventricle. So we will start from here. I hope you're able to see that. Anyway, what is happening here is that I'll label this number 4. What is happening at number 4 is, according to our phases, the mitral valve is open, so obviously the pressure is below 8. All right, and then you still have blood coming in from the atria to the ventricle. But we then see that the ventricle starts to contract and the pressure increases. And when the pressure increases to just after 8, we see that there is closure of the mitral valve. Now, call this number 1. So what you get just at the closure of the mitral valve is known as end systolic volume. All right. Now, once the mitral valve closes, you find that there's not enough pressure to open the aortic valve. So what will be happening is that pressure will keep on increasing, but it will be doing so against 2 closed valves. So because that is happening, we call this isovolumetric one volume contraction. All right? But when it reaches at about or after 80 millimeters of mercury, you find that then the aortic valve is going to open. When the aortic valve opens, you have the fast ejection and the slow ejection. But remember that at this point, we still have contraction going on of the ventricle, so there is still increase in pressure, all right, to about 120. Okay, so at this point you have stroke volume. Okay, you have blood coming out of the heart. So because blood is coming out of the heart, you'll find that the volume is decreasing. When it comes down, well, this diagram is putting it at 120. I'll put it maybe this way, okay? When it comes down to about 100, that is when you see the aortic valve close. And once the aortic valve closes, then relaxation will continue, but against 2 closed valves. All right, so this is number 2, and this is number 3. So between 3 and 4, you find that there's relaxation going on until the pressure goes below 8 and the mitral valve opens again. So this is something that you should learn how to explain. And of course, the volume that is going to remain in the ventricle after contraction is known as the end systolic volume. Okay, end systolic volume. All right. You can look up Ganong or Guyton to see how their pressure look like. But now what I want to bring to your attention is what may happen in terms of the indices. So what changes can happen to this particular one loop if there is increased preload. So if there's an increase in preload, we say there will be an increase in the end diastolic volume. So our end diastolic volume was here. So it means it will increase to, let's say, 140 from 120. So if it increases from to 140, what will happen is even what you're taking out will be more. So your stroke volume will be more. Let me see if I can change the colors here. So from here, it will go all the way to here. This is where number 1 will be. And then you still have the isovolumetric contraction. But what you will see is that your stroke volume, which is this part now, has increased. Okay, so it will still come down to a very similar end systolic volume. So this is what happens when there's an increase in preload. Number one, you have the amount of blood being ejected being more, the stroke volume will be more, and then you will find that the end diastolic volume will also increase. And why would the end diastolic volume increase? Let me just give you a second. Okay, so now let's look at what is happening in the afterload increase. So if we have a situation where afterload increases, so this may result because of increase in aortic pressure. So there's more pressure and that means there's more pressure that the ventricle has to work against, and this implies that stroke volume will reduce, and it will also result in an increase in the amount of blood left in the heart because there was not much taken out. So if we're going to increase end systolic volume, it means we're going to move a little bit to the side, so can maybe be at 70. Okay, and we are saying in this case that stroke volume has decreased. Okay, so we will maintain where we were in terms of end diastolic volume, so it will go to move this way, and then the isovolumetric will be the same. Okay, but what you're going to see is, because we're beating against a higher resting pressure for the aorta, this pressure will actually go a little bit higher, all right? And then of course we said we will have a reduction, so it won't go all the way to 50, but it will be, let's say, at 70. So this will reduce. Okay, so stroke volume has reduced, therefore the amount left in the heart is more. Okay, all right. So these are the two ways in which these loops can change. The last loop that I wanted to talk about is increased contractility, and I'd like you to go to Ganong and just see how that affects this loop. You can start by ensuring that you know that the ventricle has developed a greater tension during systole, and so you will have to see an increase in the amount of stroke volume. Okay, so if you're going to see an increased amount in stroke volume, you want to observe a reduction in end systolic volume. So let's see how you can draw that. Okay,